So today we'll talk about dynamic models, testing, governance, and implementation. Let me walk you through our agenda for the day. So we'll start with our business case. We will talk about lending application first-party fraud. So I'll walk you through the detail just to give you some context in how we implemented our first dynamic model here at CIBC. Then we'll go over a very brief definition of dynamic model, look at some of the benefits, some of the challenges, again, pretty high level here. Requirements for the dynamic models. I will not go through the entire list of requirements because that would be quite cumbersome, but I will focus on two elements that were crucial for us, which is the model development pipeline and also the model registry that you will need. Then we'll talk about testing, particularly about the additional layer of testing that you will need. So you not only need to test your model and your output, but there's a process around the dynamism of the model that also need to be tested. So we'll talk a bit more about that. And then finally, we'll end with automation and governance. And really what we're talking about here is the human in the loop. So we'll finish on that note. Let's look a little bit at business case. So about 3 years ago, my team implemented a series of machine learning models. There's a total of 6 models, actually. And they basically are there to detect first-party fraud. We have those across different products, unsecured lends and loans, also secure lends and loans, mortgages. And they are across our 2 brands, which is Simply and CIBC. Throughout our process of putting these models in production, we did build a robust pipeline, and I want to mention it here because you'll see in the next step that this became kind of key in our journey to dynamic models. So this pipeline optimizes the parameters, reduces the dimensionality, and also by increasing the robustness of the model, it allows us to increase its shelf life. The process itself, where these models sit, so that's what you have at the bottom. It is a daily process. So we are reaching to the data source overnight. So every night we look for all the applications that happen during the day. The model executes overnight. And the next morning we are sending the alerts to the investigators that will then review the alerts. And then they will determine whether it is a possible fraud, a suspicious fraud, or the next one is confirmed fraud or a false positive. And then we actually have already a loop back. So when we build these models, we had the intelligence that was accumulated from our previous investigations, and we use that to build a model. So that was already existing. And you'll see too, as we go through this process, that became key for Dynamics model. Finally, when we implemented these models, we outperformed the whole system. We saw quite a big increase in the reduction of the false positive. And also we did increase our risk coverages in some of these cases. But those were static models, right? That was kind of the beginning of our journey here. Those were a series of 5 to 6 static models that we implemented. Now, where's the opportunity to go into dynamic model, right? So I have it here on the screen: system, strategy, macroeconomic, process changes, right? And I'll go over 2, right? Because again, this should be nothing new here, but we think of COVID, right? A lot of our models were built pre-COVID, then COVID happened, and then all of a sudden we were using cash checks, no longer. We were now using online data, much more EMT transfer, were much more frequent email transfer. So the behavior changed very sudden, and our models that were static just weren't adapted for that. Some models fare better than others. I do monitor a pretty large number of models for CIBC. So some models actually could weather the storm because the behavioral patterns did not change that much for that specific model. But other models we just had to decommission completely because they just, weren't efficient anymore. The same thing will happen when there's process changes, right? A lot of time we hear lift and shift from a technology team. They're just changing one platform to the next, nothing changed. But next thing you see is a 0 is now recognized as a missing variable, or vice versa. That creates quite a shift for our models that are static. And all of a sudden, because of that one variable, you need to, again, decommission the model or rebuild, right? So those are 2 examples that really kind of create the opportunity for us to move into dynamic models. There's more, but we'll just limit to that for now. All right, what do we mean by dynamic models? So I talked a little bit about that already. Is something has to change in your model, right? Usually we would develop our models, we will have our code, and they stay as is. It's static. The variables doesn't change. The algorithm doesn't change. The weights attributed to each of the variables would not change. So everything is static, right? But with a dynamic model, at least something has to change, and it has to be on a cycle, right? It has to be, is it weekly, monthly? In our case, I can tell you, we went with a monthly process. So there's a monthly model change that is automated. That's how we implemented the cadence for dynamic models. But again, that could be weekly, could be yearly. If beyond yearly, I mean, maybe we can debate that later. Is it really a dynamic model, or is it just rebuilding a new model every year, right? But anyway, I think you understand that you have a process where something is changing in the model is adapting to the feedback loop you have to the new data. All right, so why would we do this? Well, we talked about that. Is reduce the impact of the model drift, let it be from the process, the data, or even macroeconomic events that happen. Technology cost savings, and that will depend, right, on your organization, but also on your line of business. Sometimes model change can be fairly cheap because you have all the data requiring the systems are fairly easy. Other times it would be quite costly, and it could be a very, very extensive project to replace a model, especially if you talk about real-time system, decisioning system, right? Those tend to be a bit more costly. So again, with a dynamic model, there's going to be some savings because we're not going to change the model every time. It should last much longer. And not only would the models last longer, but the performance would be maintained. And that's a bit theoretical, but obviously you can imagine if you build a new model every month, that model should always outperform the new one. Then your performance throughout the life cycle of the model should be maintained at a higher level. So there should be benefit there. And I say should because we started in January, right? So we built our first dynamic model in January. So we have maybe 6 months now data. So we don't have enough to see that, right? We'll probably need a year or two to see, and then 2 years down the line, then we can see, yeah, this is how much saving we had because the performance was maintained. We didn't have to change the model when an event happened and whatnot. So in the long term, we'll be able to see, but that's in theory. What we would hope to see is a much better performance in the long term. A few cons here, obviously, it's a complex process, so you do require model registry. We'll talk about that in a few minutes. Additional controls will be required, especially at the process level, as I talked in the introduction. And finally, your explainability of the model is a bit more complexified there because you have to look which model was on at that month, right? So if a client asks me why was credit accepted, refused, or in this case, why was an account alerted for fraud or not, then I would have to go back at that time, what was the score of this client from a fraud point of view, and then I would have to go look what model actually was in production at that time. So it had that extra layers of complexity when we talk about explainability. All right, moving on. Requirements, and this is where I'm going to talk about two main requirements. The first one is at the top, is our automated development pipeline. So in our previous process, I have to say we've done quite a lot of XGBoost model. I'll say we're definitely expert in the implementation of these models. And throughout the years, we developed the pipeline. You see there, it's pretty basic. There's more details, but for today, I wanted to keep it fairly high level. So we start with optimization of the hyperparameters. Then we do a feature selection based on clustering and Shapley values. We then re-optimize our parameters. And then finally, we optimize the number of threes. And we do our cross-validation for the XGBoost model. So that pipeline for us was has already gone through model validation. We've already measured this again, our risk policy. We know that this is in line with our guidelines, and this is in line with our risk appetite. So that was key because there was kind of a big chunk of the model development automation that was already in place. So basically, we use that at the core of a dynamic process, and then we're able to move along into our journey here. Second thing that's really important is about 2 or 3 years ago, my team, we moved our monitoring process to Databricks. And that was for us really what started our journey in dynamic models, because all of a sudden we had Databricks, we had capabilities from a model point of view we didn't have in the past. And also this led us to using MLflow. And MLflow was really essential here because you do need a registry for your models. We need to record all the tests. We need to know also which model ran and what when was it decommissioned, right? So you need all of that record keeping. Without MLflow, that wouldn't be possible, right? There's probably other software that can do that, but for us, MLflow again was key in the development of the dynamic process we have here. So 2 things is the automated pipeline and the model registry within MLflow. That was the 2 key elements that allowed us to do dynamic models in production. At the bottom, there's a few things I added there. Alignment with model and guideline. I kind of talked about that. Our pipeline reduces the dimensions, make sure that our models are not overfitted. So that already existed for us. So I know that my dynamic process is in line with my modeling guidelines. Finally, historical data. And that's just another thing sometimes to think about is if I need 1 year of data because of my target or my performance, so I'll have 12 months, I can build my model with 12 months, but here this is not going to be sufficient because I'm rebuilding my model every month, right? To test that process, I need at least another 6 months, right? Maybe even another year. So easily, again, it depends on the case, depends on the cadence of the dynamism of your process, but you can easily double the requirement from data, where if I not just need 1 year of data for a model, for a dynamic model that changes every month, I easily need 12 months, which lead me into testing. So I'll take a pause from machine learning just a second, and we'll just go into, I'll go on a sidetrack here. About a year ago, I had the pleasure to meet Megan Chika. She does analytics for hockey, especially. I play hockey, big hockey fan here. So I was really intrigued, and I've always wondered, how do they predict games, right? I also watch a lot of footballs on Sunday, and that too, that was the same thing. They talk about their models. I'm like, which kind of model is there? Because obviously I work in models. I'm like, is it a series of model or whatnot? But Megan at that presentation basically answered, she said, well, I have 7 models competing every night. And I just thought, oh, that's such a good idea. And I was like, I think there's something we can do here. So here comes the champion challenger that we built, right? So, and again, that's kind of the light bulb here that say, okay, we can do dynamic models. And rather than change the model every month, just, we change it because we have to change it. We have a contest that happens every month. So our model in production is our champion model. And then our automated process will build a challenger model. Then we will have those 2 models compete head to head. So that's where we did a lot of testing. We tested that process. We said, what are the metrics that would decide whether or not we change model, right? So we landed on 3 different metrics, and all 3 metrics have to be improved for us to change the model. So now we're not just talking about, as I said, changing model every month because it's the end of the month, we're going to change model. No, it's more like, okay, here's a new model. Is this new model going to give us the benefit we want before we change, right? So that entire process is automated. And we'll start talking a bit more at the end about the human in the loop there. But we automated all that. And then we define our metrics. And again, I say we because it's in line with our risk appetite. Obviously, in your organization, you might have a different approach. You may use different metrics depending on the process or your organization also right there. Requires a longer time window. We talked about that already. And so you have this new kind of testing layer, right? My champion challenger, my dynamic process has to be tested. On top of that, I still have to test my model, right? So here for us, what we did is we used a curated pool of variables. So the model doesn't go every month and just pick whatever variable he wants that are available. No, there's a curated pool of variables that we say, okay, these are your variables you can use. And from a governance point of view, again, being in a regulated environment. We just need to make sure that we have the proper governance on all of those data, right? So is the source reliable? Is it maintained? Is this data good? Or, like you cannot, as I said, you cannot just use any variables, because you need just to make sure that proper data governance is maintained on those variables, and you understand and you have a proper definition of those variables. So for us, that was our way around it, is to create a pool of variables that the model can select. Second thing too is we decided to have a static model type. Don't be disappointed, it's still a dynamic model, but the choices of model every month doesn't change. So for us, it's XGBoost. As I said, we do have quite a lot of expertise with that algorithm, and we have that pipeline, so it's XGBoost. So that will stay for us. It's always going to be a new model, but it's always going to be XGBoost. That can change. Again, depending on your process, depending on your risk appetite, you could let the algorithm decide on its own model every month. Again, everything's possible there, but again, for us, that's where we kind of put the boundaries. No, it would be the same type of model, and it would be within the variables available. Finally, I'll just say regarding outcomes that you still need to do your regular testing that you would do, right? For us, with qualitative review of alerts. So that's just a regular process, right? When we implement a new model. So that too still is in play here. And finally, the thing I put there is impact on false positive. And this is not just true for dynamic model, but I think as someone that went through a lot of implementation of models, I think that sometimes people overlook that, is that our models tend to be pretty good, right? That's why we implement them. So having a dynamic model, we know that that level of performance will be maintained. So you will reduce your false positive considerably. So in the case of a fraud, I always like this example, because if you had 100 alerts every month, right, and you have usually 20 fraud in that, and now that process changes, you have 50 fraud. Well, fraud takes a lot more time than a false positive, right? So I find sometimes the front line are not prepared for that, where they're like, oh, wait, I went from 20 hours to review fraud to 50 hours, right? It's huge, right? The model is doing its job. It's performing much better. We still have the same number of alerts, but in the front line, it does increase their output quite a lot because of the additional fraud that is detected, right? So I think that's something to consider. I put it in there again, not necessarily just for dynamic models, but always something good to keep in consideration. All right, human in the loop. So this is the last point I wanted to bring here is, and the first question is right there, what level of automation are we comfortable with? And I think that's really key when you think about governance and validation here, right? For us at CIBC, when we developed this process, we worked in tandem with our model validation team, right? So all of models have to be vetted by a third party internal to CIBC, our model validation team. So that process is still true. And as I said before, we could have automated this entire process without us touching. Every month, we would have a competition of the models. If the model meets all the criteria, the new models will be put in production. We will decommission the other one. All of that can be automated. However, what we decided, again, to be in line with our risk policy and our model policy, what we decided is that we kind of stop the process, still dynamic, but here what we do is when there's a model change, when the challenger model wins, we do like fill out a model development documentation, and we do a submission to model validation, just as any regular model change. However, here that process is not as long as a usual model. And it's not because their validation is not as thorough as it usually is, right? No, because they already validated the dynamic process itself. So there was a validation at that point. So they know which algorithms we're going to use. They know which variables we're going to use. They know the process. They know the criteria for a model change. So all that's already been approved. So here, all is left to approve when the model changes is actually the new model itself. So we can go through that validation much faster, but still apply the same rigorous criteria that we usually do for validation. And that allows us to, again, put the human in the loop, put some control in there. So we send to model validation, we validate the model, we're okay with it. Okay, then we can put it in production. So again, so it allows us to make sure that there's some control in the process, that we're not just changing model to change model, as I mentioned. And again, it's in line with our risk policy. And again, we show that we have control and we understand what is going on. So we stay away from, I really don't like that word. That's a discussion we can have after when people say black box. I think it's not because they're machine learning model, they are black box model. We do understand what they are doing. We do understand what are variables in use and whatnot and how it works, right? So I think that human in the loop was essential for us. And again, that's another key element that allows us to move towards dynamic model. And maybe I'll end with monitoring challenges. Something to think about too is our model changes, again, not every month, but almost. Then, what's my baseline now, right? When we do our monitoring. So that's something we're looking into. Maybe I have 2, maybe even 3 baseline to monitor our model, just so we keep track of the performance. As I mentioned, we want to also keep track of that long-term performance and see what those benefits are. So that's another thing from a monitoring point of view that we're discussing and looking into. And that's, I put there, our usual relative thresholds still applicable, right? Or do we need new thresholds? So again, so we're developing, right now we're kind of monitoring almost as a regular model because we haven't had too many change, but as time go, we will definitely increase our monitoring to make sure it's in line with the risk that the dynamic model can present. All right. Not too bad. I did it in 20 minutes. So I did want to keep some time for questions. I know some things I went high level, so I'm more than happy to go into more detail. So if there's any question, please send them my way now.
We also have some in the chat here, Frederic, so I can read some of these. Stein says, have you implemented model serving points in your production environment, in Databricks?
So yeah, so this dynamic models are implemented in Databricks. I don't know if that's the question, but yeah, they are in production. In our production environment is Databricks, and that's where we have ML flow, and we have our entire flow is all within Databricks.
Awesome. People ask, can you comment on training or ML dev policy changes you had to make in order to move to the dynamic model workflow? Example, convincing team members to adopt model registry, etc.
Yeah, no, that's, and I think we're talking about like model validation, even model audit. So we did prepare, I always say like we had a road show, but in a way, so we did prepare probably a year ahead of time before implementation easily, as we were starting this journey to make sure that from a, our model policy is owned by model risk policies owned by model validation. So that was for us, our main stakeholder here. They had to be on board. So as we went through this journey, we, kind of walked them through it, making sure that we had all the right steps and all the right documentation. And I think the biggest, I'll say, point that came in there was really the additional, I'll say, and I don't want to say additional or stop because it sounds like they're stopping the process, but they're not actually. Model validation did say, okay, every time you change the model, we want to see it and we want to approve it. So that was probably their biggest input. My team, we thought it would be just sufficient to let them know we changed the model, but again, they own the risk there. So they were like, no, we want a full check. But that full check is happening much faster, so it doesn't impede our dynamic process too much, I will say. And again, it's because of that collaboration we had. So, but yeah, like throughout that process, I'll say a year out, we talked to our audit team and obviously also my executives, within risk. I had to convince them of this. But the business case was there for itself because, we've all lived through COVID. We've all lived through a system change, and then you have to change your model because of one variable or whatnot. So I think the business case was fairly easy to convince from a risk point of view. And as long as all the model risk, the new model risk that comes from such a process like that are taken care, I think then the journey was fairly, I don't want to say easy, but fairly smooth. Let's use that term.
Thank you. Thanks, Fred. Okay, we're going to keep this rolling because there's tons of questions here. Rakesh asks, the computing model technique is comparable to voting or assembling, or is it fundamentally different here? Also, are there any packages that allow you to implement these techniques?
So for us, I have to ask my technical team which packages they use. So I know they use MLflow quite a lot. And really what we have on a monthly process, like for us to know whether or not we change the model. So we basically just use our model development pipeline that we have. It's all used, they all coded in Python. Which package exactly they use, I can definitely get back to you. I have my modeling team let you know that. And then basically, so we have our development process, the pipeline that's automated, that runs into our flow. And then when we decide the model, for us, it was, again, we set new model versus old models, and then we looked at 3 different metrics. And then those 3 metrics have to be passing that old model by at least 0.01. You know what I mean? So as long as they pass it on the 3, then we would change the model, right? And just to give you an idea, our monthly process, we end up changing probably the model twice a year based on our testing, right? So it's not, again, I kind of want to emphasize on that. It's not something that happens every month. The model will change once or twice, and it's really when there's a need, right? When there's an event, when there's a variable no longer is predictable, then the model lost its performance. New model comes in, obviously will not use that variable, and then that's where the gain happens here.
Perfect, thank you. Okay, Rakesh asks, the competing model techniques is comparable to. Oh, that's the one I asked, sorry. Frederic, very well decision on Databricks ML flow and monitoring of the models becomes quite easy with this. Yes, XGBoost certainly is great. I hope you have tried Light GBM. Which of the models score came out significant over this period? Did you recalibrate, retrain, post model drifts?
Sorry, can you repeat that?
Yeah, Frederic asks, which of the models score came out significant over the period? And did you recalibrate / retrain post-model drift?
So that's, I think I'm going to answer your question, but our testing, and that's what I was kind of referring to, where you need that additional year of data, right? Is that we tested, and you do need a lot of computing power, I will say, because we tested everything. We tested, should we look back 6 months or 12 months of data? Should we look at one metric or 2 metrics? So every time you test, it's not just one model, but it's, a series of models every month that you build. So again, that's where, your testing become exponential. So I'm not sure if I'm answering the question, but I'll go on this track anyway. But basically, that's something that you need to be aware here. It's one models easily becomes 144 model because you have 12 versions that you want to do for 12 months in the year. So as I said, it's almost exponential, the number of models you're going to have to build to test. And I will say test everything, right? Test your variable pool, test which metrics are used for the change of model, test the frequency of the change, right? We went with month, but I'd love to hear if someone has a lot of coming data, real-time data coming in every second or whatnot. Maybe you can rebuild a new model every day, right? So I think there's some process that may lead to a higher frequency. Again, for us, we tested different things, and monthly was where where it was good. And you know, our champion challenger, the testing, it was really interesting because we tested one metric, then you have to run it for like a year and see, you know, well, a year of data, right, historical data, and then see when does the model change, whatnot, evaluate the performance of that process. Then you try something else. And then again, you have to run 12 months again, but now with these new thresholds and see what's the overall performance, right? So, it's, you know, I think it's fun, but it does require, as I say, that additional testing layer that dynamic models do. A bit more complex, but I think definitely worth it. And maybe too, I'll add something here is, I've heard at a conference somewhere like, oh, we're not ready, or we don't have the systems or the process in place to implement such model. And one of the things I wanted people here to take home is really, no, you do, right? We do, and I think we're ready, even in a regulated environment. I think with the proper controls and governance, this is something you can do now. And I think this is, you know, the proof of it. And definitely this is, I hope it inspires people to go on this journey too, because we have everything we need, right? And again, we're quite familiar with this algorithm. There's no more black box here. We know what they're doing. We know how they're performing. So yeah, so I hope it helps for that. Maybe one more question.
Yeah, one more question. We have, what are the 3 metrics that need to improve to change the model you covered?
Yeah, and you know, there's nothing too fancy, I'll have to say. For us, being a fraud model, we looked into our classic area under the ROC curve was one. Then we also look at the recall precision curve, and it's either F1 or F2 score. So I'm not sure which one they use. But for us, it was like those 3 scores that are calculated had to be improvement in not just one. And that's what gave us the most robustness. Otherwise, if we only look at one or the other, it could change for different reasons. So with these 3 metrics, we felt we had a good understanding. And again, it wasn't changing just randomly or just because it needed. It was really, no, there's net improvement for changing at this point. And I didn't want to mention the metrics because I think they should be different for every process. I don't think that should be a recipe that you take. You know, it could have been, you know, fraud caught, right? It could have been something much more process related. But in our case, that's what worked the best. But again, as I said, this should be thought through and process driven rather than recipe driven. I don't know if we can say that. But yeah, I just did. All right.